Our running theme, Grace, has been, I've been trying to tell you, there's lots of information on that periodic table. What we're going to start talking about today is what you can learn from how it's laid out, from its structure, by counting over from the left side or the right side, and how far. I always start off with lame chemistry jokes. I heard that oxygen and magnesium were going out, and I was like, OMG. Okay, there you go. Atoms are made up of, what are the 3 subatomic particles that make up atoms? You know what? We have an abbreviation for that, don't we? What's the next one? We usually go in this order because those two kind of fit together, because where are they?
In the nucleus.
Okay. And then the third one, which actually ends up being really important now, is electrons. The reason these are so important, Brooke, is because they're outside the nucleus, we can move them around. We have the technology. It's what all electricity is based on. It's not a coincidence that electron and electricity have the same root word. We're good at it. Then we have, we said this, the atomic number is the number of protons. So if it's an atomic number of 17, that means it has 17 protons, and that tells you its element number 17, which is whatever element number 17 is. What is element number 17? Chlorine? Okay. You all have your periodic table in front of you. Some of you are turning around to look at the back. That works too. Now, the number of electrons in a neutral atom before we muck around with it equals the atomic number as well. In other words, if an atom is neutral and chlorine has 17 protons, you know how many electrons it has? 17. But that's boring. And generally, atoms don't like to remain neutral. Only a few do. Generally, they like to react. And all the reaction occurs by grabbing or giving away atoms. By sharing atoms, by stealing atoms, or by giving them away. Sorry, atoms. Electrons. I said atoms. Electrons. So I wrote here, although normally the number of electrons in a neutral atom equals the atomic number as well, this changes when it becomes a charged atom. Who remembers the 3-letter word began with an I that we called a charged atom, when it becomes an ion? And this next bit you want to put a little star next to, because I'm definitely going to expect you to be able to do this on a test. Here is how you calculate the number of neutrons. Oh, I have a lovely abbreviation for neutrons. Neutrons and zeros. If you want to figure out how many neutrons an atom has, it's the rounded off atomic mass take away the atomic number. Can I use the number sign as my abbreviation? If that's okay, I hope. Let's look at chlorine again. How many protons does chlorine have? 17. What's its mass? What's its exact mass as a decimal, first of all? 35.5. If you rounded that off properly, what would that round to? Okay, if you go 36, take away 17, that's how many neutrons. What is 36 take away 17? This is why I said you can now start bringing a calculator, or if you're comfortable going 36 take away 17 is 19 neutrons. 19 neutrons. Okay? Not 9. 9 is a German student saying no. 19 is the correct answer. Okay? Hey, can you find, I'm just making this up, can you find element number 23? What is element number 23? Vanadium? Vanadium? Never used that one before. What's its mass as a decimal, first of all? That one's easy to round off. What would you round it up? 61. So you would go 61, take away 51 or 61? 51. 51, not 61. So if you go 51, take away, what's its number? That's how many neutrons. 51 take away 23 is? So I'm suspecting on Tuesday, many of you will have a cheap calculator. And it can be a totally cheap one. It doesn't have to have anything but adding, subtracting, multiplying, and dividing. Okay? What is 51 take away 23? Well, you would go 51 take away 20, which is 31 take away 3. I'm pretty sure the answer is 18. 28. No, 18. No, 28. You're right, 28. 28 neutrons. Okay? I tend to use a calculator on a test. I tend in my homework to try and do it in my head because I'm lazy and I like to practice mental math. I am on your test. I guarantee you I like this question, I like this question, I like this question. I'm going to give you an atom and I'm going to say, how many neutrons does it have? And the most common mistake is I say, go find element number 51. How many neutrons does it have? And kids say, 51. No, that's how many protons. What's the mass of element 51? What is element 51? Antimony? Okay, what's its mass as a decimal? 121.8, so if I round that off, 122. So it would be 122, take away 51, whatever that is. Generally, you find as you go further down, you have more neutrons than protons. And it turns out that's what can make atoms, nucleuses, unstable. For example, uranium, which is really unstable, it's what we use to make atom bombs. It's got so many neutrons that if you hit the nucleus just right, you can split it. And if you've heard the term splitting the atom, that's what they meant. You look at that in Science 10. Hey, let's practice some. Let's do carbon. You guys have this in your, did I include this in your notes or not? Yeah. Yep. Okay, so let's fill in this little chart together. Atomic number of carbon, we're going to go all the way down. Atomic number of carbon is what? 6. Yay, that would be fair to ask you on a test. What's its symbol? What's its mass? 12. How many protons?
6.
How many electrons when it's neutral? 6. How many neutrons? And I'm going to write here, it's 12, take away 6. So in your notes, you know what we did. In the homework, Brooke, if you can go straight to the answer, I'm fine. But in our notes, we'll write. Okay? Hang on. Copper. 29. Stop. Look up, look up, look up. I can now fill in that one and that one. Those are the same. 29. The reason it's element number 29 is because it has 29 protons. And when it's neutral, it has 29 electrons. Symbol. What you sometimes text to somebody. As a nerd, when I see that, I think, what, copper? Huh? Anyways. What's it weigh? What's its atomic mass? Round it off, please. Well, first of all, as a decimal, what is it? 60. Okay, so I'll write here 63.5. I'm going to use, because if it's 0.5 or higher, you round up. Remember your Math 8 rounding rules? So how many neutrons? It's going to be 64 take away, which is what? Well, 64 take away 30 would be 34, so take away 29 would be 35. I grew up without a calculator, so I have lots of tricks for doing math in my head. Again, either do the math in your head correctly or bring a calculator. What I will not let you do is use your phone. Too easy to cheat, because there's apps that will do all this for you. Neon. 10? And I know neon is Ne, yes?
Yep.
Oh, did you say 10? Well, then it's also got 10 protons and 10 electrons. What's its mass? 20.2. So I'm going to use 20. Again, in your notes, if you just write down the rounded off mass, I'm fine with that, Brady. Sorry, in your homework. In our notes, I'm putting that so you know when you're studying later on what the heck, where that 20 came from. Oh, this I can do in my head. 20 take away 10. Okay?
You got it.
Lithium. 3. Oh, so 3. Oh, I can finally explain a joke today. What's the block order today? What's the block order today? Listen, no, you're all wrong, you're all wrong, you're all wrong. Listen close. The block order today is iron, mercury. Think about it. It's iron, mercury. Thursdays are iron, mercury days, and I can finally use that. I've been waiting all year to use that joke with you folks. What's the block order today? Iron, mercury. And now, hopefully you can all tell time. Now that one there is in binary. That one's trickier. I'll explain that some other time. But at least this clock behind me, if I say to you it's oxygen minutes past lithium, you should be okay. I hope. What's lithium's mass? 6.9. You know what? 7. 7 take away 3. Drew, you're going to get this one right. Thank you. Hey, which only one element has no neutrons? I heard it. Hydrogen has a mass of 1. It has 1 proton. 1 take away 1 is. There's a reason I was saying to somebody, hydrogen is special. One of the reasons it's special as well is it's the simplest possible atom. 1 proton, 1 electron in a shell. You can't get any more basic than that. Remember how electrons are arranged. We said that they are arranged in, I just said the word, begins with the letter SH. Shells around the, what's at the center of the atom? Nucleus. How they are arranged determines how they combine and react with other atoms. What I tell people is that's the alphabet of the universe, and what you're about to do this year is learn how to spell 2-letter words. Won't get much past that, but it's a start. It turns out elements are related to each other, if they're in the same family or vertical column, if they have similar properties. The reason everything is in the first column is those atoms have similar properties. And the reason they have similar properties, the reason all the alkali metals have similar properties, the reason all the alkaline metals have similar properties, the reason all the noble gases have similar properties is because their electrons are arranged in a similar way. Turns out, for example, all alkali metals have 1 electron in their outer shell. You may notice on your periodic table that the alkali metals are in column 1 and have 1 extra electron that they'd like to get rid of. They're in column 1 and they have 1 extra electron in their outer shell that they want to get rid of. It's also why they're so reactive, because it doesn't take much effort to get rid of 1 electron, and they really want to get rid of that 1 electron. All noble gases have full outer shells. And because they have full outer shells, you really have to basically in a lab do something fancy Jaden to get them to react. They don't want to. They don't want to. The electrons in the outer shell determine how the element reacts. We have a fancy name for the outer shell. You need to, this will be a vocabulary word, so you may want to put a star next to this, although I'll use it so often, I think all of you will memorize it naturally. We call the outer electrons valence electrons. You're going to hear me talk about the valence shell of an atom. What I'm talking about is the outer shell. In fact, I wrote here, valence electrons are very, 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 very important. Valence electrons would be like the rules for spelling 2-letter words. You with me? Yeah. Call them attention span. You're fine. Niels Bohr, we talked a little bit about him in the last unit, was the first scientist to show that electrons existed in shells. I don't think I gave you this picture, did I? No, that's okay, it's up here. He developed models to show how they were organized, and this is what I mentioned at the beginning of class. So it turns out, let me zoom in here a little bit. Grace, is that big enough for you to see at the back? So here's hydrogen. It has 1 electron, because its element is atomic number is 1. Helium has 2 electrons, and this first shell can only hold 2. Now the shell is full. If you tried adding an extra electron, it would end up in the first electron in the second shell. Lithium has 2 inner electrons and 1 outer electron for a total of 3. Beryllium has 2 and 2 for a total of 4. if I go all the way across, neon has a full outer shell, and you can see fluorine just needs one more electron to have its full outer shell, and it really wants its full outer shell. That's why it'll melt lots of, like fluorine will melt glass. It'll react with anything. It wants that electron. It's going to rip it off anything. And when you rip electrons off, Brooke, stuff starts to behave differently. You with me? Okay. So what's the pattern? Well, how many electrons does the first shell hold? Can you see it? 2. How many electrons does the second shell hold? Can you see it? 8. Can you see it on your pink table as well? It's just read across. How many electrons does the third shell hold? Also 8. The fourth shell holds 18, and after that it goes a little weird. So, as you move across the periodic table, the number of electrons goes up by what? By how much? By 1 each time. As you move down the periodic table, the number of shells increases by, when you move down a row, how many shells do you have? 1 more. Each time you, so at the very, very bottom, some of those have many shells, but again, then here it's starting to overlap and they're starting to intertwine, and much of what I'm telling you is wrong. But certainly potassium, find potassium, how many shells does it have? 4. Everything in that row has 4 shells. Okay? If you want to distribute electrons, and you'll need to do this, but we'll practice this a lot. First thing you want to figure out is what row it's in. And remember, row, another word for that is period. This tells you how many shells there are. And if you're trying to draw the atom, it also tells you that the inner shells are all full, the ones above it. Only the outer shell will have, I'll call them holes, I don't know, missing electrons. Gaps. That'd be, you know what, next year I'll use the word gaps. That's a better word. Then what you do is you count over from the left. Boom, 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 boom. And that tells you in that outer shell how many electrons you're going to put. We call this drawing a Bohr model diagram, and you're going to be drawing lots of those. And on your test, I will ask you to draw a Bohr atom. We'll practice this. I wrote here, some students choose to remember the 2, 8, 8, 18 rule. Can you see on your periodic table where that comes from? 2, 8, 8, 18. I don't know if the 18 is so crucial. I do have the 288 memorized because it's just less work than looking it up all the time, and those are fairly easy numbers to remember. Then what you're going to do is you're going to fill in the inner shells with pairs of electrons, and then it says organized as shown below. I'll show you in a second. Then you put the electrons in the outer shell in. You put the first 4 around the shell, and then you pair them. A picture is worth 1,000 words. I think on the back of your notes, I gave you a little dotted line circled diagram, didn't I hope? Okay, okay. I couldn't fit it on this page. So we're going to draw a picture of carbon. You know what? Let me zoom way in so you guys can see. Okay. First thing I usually do is I go carbon. This middle circle is the nucleus. If I have room inside, or if I can't fit it inside, I'll put it in the margin somewhere. What's carbon's atomic number? I'm going to ask you the same question. I want the same answer. I'm just going to phrase the question differently. How many protons does carbon have? So I usually write this. How many neutrons does carbon have? How will you calculate that? What take away what?
Well, take away 6.
Also 6. How many protons?
6.
How many electrons? 6. So you ready? How many electrons can I fit in the first innermost shell?
2.
1, 2. And for reasons that I'm not going to go into, they pair together. How many have I drawn?
2.
How many more do I need to draw to get 6? So look up watch, please. What you do is you put 1 here. The next one goes at a right angle like a compass. The next one goes at a right angle like a compass. The next one, there's the 4. That's a Bohr model. Now, if I had to add more electrons, I don't. But if I did, then I would start to pair them up until I was full. Don't write those last 4 down, please. Gone, 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 gone. Okay? Yes? It does it wonky, I know. And there's some inconsistencies, I know. And I wish they would have fixed it and changed it, I know. What I will say is if you do it this way, I'll give you full marks. Then I said, let's try chlorine. Chlorine is a bigger atom. It's going to be more drawing. Okay? Chlorine symbol is what? Okay. How many protons does chlorine have? In the middle, I go 17p. How many neutrons? What take away what? 35 or 36? Okay, round off properly, because if you round off wrong, I guarantee your neutrons are wrong, right? 36 take away 17. Oh, 19 neutrons. I won't make you try and draw those. To try and fit those dots in is ridiculous. Forget it. Oh, how many protons?
17.
How many electrons?
17.
So you ready? How many in the first shell? 1, 2. How many left? 15. How many in the next shell? 2, 8, 8, 18. So in the next shell, how many? 1, 2, 3, 4. Pair, 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 pair. How many electrons have I drawn so far? 10. How many do I need to draw? How many am I going to draw now? I've drawn 10. I need to draw 17. How many are left? Now, the other way you can figure that out is if you just count from the left across to chlorine. I think it's the 7th element over. So if you're lousy on the subtraction, you can actually just count across. How many did you say? I'm going to ask one more time. How many did you guys say? You're right.
7.
So it's going to go like this. Watch. 1, 2, 3, 4. Now I'm going to start to pair. 5, 6, 7. Mr. Dueck. Yes, Caitlin. What if I put my 7th electron, what if I put that guy right there? Fine. All I would look for are 3 pairs and 1 singleton, wherever you put them. I usually just go start at the top and I go around like a clock because I grew up with analog clocks, not digital clocks. It makes sense to me. Why are they paired together? It's a quantum physics thing. It's called electron spin. It's part of what we're trying to do with quantum computing. It's very, very nerdy and complicated, but trust me, they do. Turns out then, you can only fit so many electrons in a shell, and it turns out once they've taken the 4 corners, the north, south, east, west, then they like to pair up. That's, Caitlin, the reason the textbook does it different, this is also still technically wrong, because electrons aren't dots. They aren't. But if I tried to teach you right, we'd have to get into quantum physics, and I don't even understand quantum. It's weird. It's beyond me. Okay? We're going to pause here, but next class, we're going to spend more time drawing Bohr diagrams. So I'm going to write your homework. If you don't want homework for the long weekend, next weekend, you want to try and finish the coloring thing for Tuesday. Let me hit pause the video for 1 second.